Hello guys, good day to everyone. Let me just introduce myself first. I am Engineer Adams Rice Agenisha, a licensed civil engineer, a faculty member, a BSCE graduate, and a graduate student at University of the Philippines, Diliman, with a specialization on structural engineering. And this is my email, adamsricejanisha@gmail.com. So you can contact me via email or you can just search my name on Facebook or Messenger if you have any concern. And welcome to my online lecture class. So our subject is still C009, Mechanics of Deformable Bodies. So just a disclaimer, this presentation is not perfect. So it might contain some errors that need my attention. So if you see any errors or corrections that need to be made, please immediately notify me. And not everything that the student needs to know is presented here. So I hope the student will supplement this discussion or presentation. And lastly, the photos, problems, etc. you will see on this presentation is not owned by the instructor. So credit goes to the respective owners. And please do not distribute or disseminate this presentation on any online platform without my or without the consent of the instructor. So the references that I have used on this presentation, Steel Engineering Mechanics by Hibeler, Vector Mechanics for Engineers by Beer et al. For some images, for clarification, and for better visualization, I have used Google. And in some content, I have used Matrix Analysis of Structures by Casimadi. And last but not the least, Engineering Mechanics Statics by Craig et al. For some sample problems and problem set. So just a recap of our previous discussion. Alalahanin lang natin ano ba yung mga tututunan natin from the previous discussion. So from the previous discussion, we have learned that kung gusto pala natin mag-analyze ng isang real structure, mayroong mga details present on that real structure na hindi naman talaga natin kailangan for us to be able to analyze that real structure completely. So, yung mga hindi natin kailangan na details, we can disregard or discard them. And after discarding them, the resulting structure is what we call analytical model or idealized structure. So, this structure, ang laman lang nitong structure na to are those necessary information or details na kailangan natin para ma-analyze yung structure. So, yung tawag doon sa isang structure na ang laman lang is yung mga information na kailangan lang nating malaman for us to be able to analyze the structure completely is what we call analytical model or idealized structure. Another thing na natutunan natin from the previous discussion ay about sa connections. So we have learned that connections are something that bind together two or more contacting parts or simply the interface of connected parts. So ito pala yung nagdudugtong sa mga bagay-bagay, sa mga bodies in contact. Eh natutunan din natin na meron palang iba't ibang types of connections. And itong mga connections na to are characterized by the internal force or forces that will come out when you draw the free body diagram of the two or more connected parts. So, ang nagdi-differentiate pala sa isang type of connection from the other ay yung internal force that will be exposed when the connected parts are separated from each other, or in other words, kapag dinro mo yung free body diagram ng mga connected parts. So, ang mga common types of connections na natutunan natin from last meeting, una ay yung roller connection. So, sabi sa last meeting, pag roller connection, pag sineperate mo siya or disconnect mo siya from being connected to something, may lalabas na isang internal force. And usually, itong internal force na to na lumalabas pag roller, palagi siyang perpendicular dun sa surface kung saan nakapatong yung roller. Another type of connection na inaral natin ay yung pin or hinge connection. And sabi, pag itong pin or hinge connection ay dinisconnect mo from being connected to something, may lalabas na single force na usually at an angle from the surface kung saan nakapatong yung hinge. And usually yung single force na yon, pinapresent siya in terms of the components nga. So, in terms of components yung single force na yan. Usually yung components na ginagamit ay yung horizontal tsaka yung vertical components. Last type of connection na inaral natin from the previous meeting ay yung rigid or fixed connection. So, sabi naman, pag ito naman daw ay disconnect from being connected to something, may lalabas na internal force which are moment tsaka isang single force na just like sa hinge at an angle din from the surface, from the fixed surface. Pero again, just like sa hinge, yung single force na yun, it is presented using its components, usually yung horizontal tsaka yung vertical components niya rin. Last but not the least na natutunan natin from last meeting or discussion ay yung about sa frame structures. So, we have learned na yung frame structures pala ay structures na composed of straight members kung saan yung mga members na to, yung haba niya compared dun sa cross-sectional dimensions niya ay significantly larger. So, yung mga frame structures pala, ito yung mga structure na yung mga member niya ay mga slender. Slender yung mga members niya. Maninipis lang, kumbaga. Kumbaga, yung cross-sectional dimension niya, significantly small naman compared dun sa length. And last but not the least na natutunan natin, again, from the last discussion, ay yung about sa classification ng mga frame structures. So again, I just limit our discussion to frame structures kasi nga yan naman usually yung na-experience natin sa pag-aaral natin sa civil engineering. Mga frame structures naman usually, mga structures na composed ng mga slender members or mga straight members na yung length ay significantly large compare sa cross-sectional dimension. Kaya natutunan natin na may 6 pala na classification of frame structure which are plane and space trusses, beams and grids, and plane and space frames. So, yan yung mga common na structure na ma-experience natin sa civil engineering. Yan yung mga usually i-analyze natin. So, for this meeting, our goal for this meeting ay una, to understand the different assumptions made and methods used when analyzing a truss. So, dito sa meeting na to talagang mag-a-analyze tayo ng truss. Pero before tayo makapag-analyze ng truss, dapat familiar muna tayo dun sa mga different assumptions na ina-assume natin when analyzing a truss and yung mga iba't ibang method sa pag-analyze ng truss. So, dyan magpo-focus yung first goal natin. Second goal natin is to be able to apply the different methods in analyzing a truss. So, dito, kumbaga actual implementation na 'to. Mag-a-analyze na tayo ng mga truss gamit yung mga different methods and assumptions na natutunan natin dito sa first goal natin. So, yun. Dito na tayo sa first goal natin. To understand the different assumptions made and methods used when analyzing a truss. So, yun, let's start to address our first goal, which is to understand the different assumptions and methods that we will use in order for us to analyze a truss. So, first things first, recap lang tayo ng definition ng truss. Again, truss is defined as an assemblage of straight members. Guys, if you have noticed, yung mga definition natin ng mga structures from the previous meeting, lahat ng definition natin, we usually stated na they are composed of straight members. Bakit ganon? Bakit straight members lang? Straight members lang ba talaga lagi ang members ng mga structure na pinag-usapan natin? Actually, hindi naman. Hindi naman necessary na straight members yung members ng mga structure na pinag-aralan natin. Pero kaya siya naging straight member kasi nga we just limit our study sa mga frame structures which are composed of straight members or slender members. That's why puro straight members yung pinag-usapan natin dun sa definition natin ng or classification natin ng mga structures last time. Pero then again, hindi siya necessary dapat na straight. So, naging straight lang siya kasi nga, ang inaaral lang natin, puro frame structure. Nilimit lang natin yung study doon kasi nga, most of the time naman, yung frame structure yung may experience natin sa civil engineering. So, truss is defined as an assemblage of straight members which are two-force member. Kung naalala nyo pa yung definition ng two-force member from the previous discussion, connected at their ends by flexible connections, or when you say flexible connections, these are pin or hinge connections, and subjected to loads and reactions only at the joints or the connections. Other term for the joint is the connection. So, this is an example of a truss. Kung naalala nyo sa previous meeting, this is a railroad truss bridge. Yan. So, let's move on. Let's go to the assumptions that we assume usually when we analyze a truss. First assumption, the members of a truss are joined together by means of smooth pins, just like this one, at the centroid of their ends, which acts as pivots, or by riveting or welding them to a common plate known as a gusset plate. Yan, ito yung gusset plate na tinatawag. Tapos nakarivets yung mga member. So sa first assumption natin, sinasabi natin na kung meron tayong truss, yung mga members niya connected, ang assumption natin, yung connection na yan ng mga members ay smooth pin or hinge. Yan, ganyan. Yun yung assumption natin. Although minsan you will experience na ganito yung connection ng truss. So kung naalala nyo sa previous discussion natin, this is a rigid joint. So hindi siya pin joint, rigid joint. But we can still assume that this connection is a pin or hinge connection as long as yung mga forces exerted by the members on the joint are all concurrent forces. So when we say concurrent forces, these are forces na nag-intersect at a single point. So meaning, as long as concurrent yung forces na nag-act dito sa joint, we can assume na yung joint ay smooth pin or hinge connection, just like this. So another assumption that we assume when we analyze a truss is that all applied loads act at the ends of the members or at the joints. So ibig sabihin lang ng assumption number 2, if our structure will be carrying a load, kung may dadalhin siyang load, yung load na yon pwede mo lang i-apply dito sa mga joints niya. So, bawal siyang i-apply dito sa katawan ng bawat member. So, bakit bawal? Bakit bawal mag-apply dyan ng load sa katawan ng member? Kasi nga, yung mga member natin, two-force member lang or two-force body. So, when we say two-force body, yung mga forces na nag-act sa kanya ay nag-act lang sa dalawang points lang. So, in the case of the members of the truss, yung dalawang points na pinag-uusapan natin na yun ay yung dulo-dulo lang ng mga members ng truss. So, dun lang sa dalawang dulo na yun, or in other words, sa joints, pwedeng mag-act yung mga forces or mga load na dadalhin nitong truss natin, truss structure. So, that is our assumption number 2. Another assumption is that yung mga weight, kasi syempre yung mga trust natin, yung mga members ng trust natin, in reality, may weight yan. Yung mga member niya, may bigat yan. Which is dinadala rin ng structure. Usually, syempre. Kaso lang, when we analyze a trust, dito sa mga pag-uusapan natin, ang assumption natin, yung weight ng member na yon, yung weight ng mga member niyan, compare dun sa loads na dadalhin ng truss are significantly small. Ibig sabihin, kung i-compare mo yung weight ng isang member dun sa mga load na dinadala nung truss structure natin, sobrang liit nung weight nung kada member compare dun sa load na naka-apply sa truss. Which is, yun naman usually yung case. Kasi nga, kung mapapansin nyo, yung mga members ng trust usually, maliliit lang. Hindi siya ganun kalalaki. Kung maliliit lang yan, syempre, proportional yung weight dun sa size niya. Kung maliit siya, malamang yung weight niya, maliit lang din. And usually, yung weight na yon ng isang member compared dun sa load na dinadala ng trust, usually, negligible. Maliit lang talaga yung compared dun sa load na dinadala ng trust. Pero, if time will come na yung weight ng member is significant na in comparison dun sa load na dinadala ng truss. If that is now the case, at kailangan na nating isama sa analysis yung weight ng truss, ang assumption natin base dito sa number 3, yung weight na yon ng member will be equally divided dito sa dalawang end niya, sa dalawang dulo-dulo niya. Ibig sabihin, kung ang total weight ng member ay 400 kilogram, yan, syempre nag-act yung weight sa centroid ng member sa gitna. Kung ang weight ng member ay 400 kilogram, ang assumption natin base sa number 3, yung 400 na yon, yung kalahati nun, dito mapupunta sa joint na to, sa end na to ng member, and then yung another half, dito naman mapupunta sa kabila, sa kabilang dulo. So, yun yung sinasabi dito sa assumption number 3 natin. So, again, assumption number 3, assumption natin, weight ng member, negligible compare sa applied loads. Pero kung hindi na negligible, ang assumption natin sa number 3, that total weight must be equally divided sa dalawang joint or end no member. Another assumption is that we are assuming na yung structure natin, yung truss natin, is in equilibrium. Meaning, lahat ng forces and moments na nag-act dyan ay balance. So, kung balance siya, ibig sabihin, wala siyang tendency to move or displace at wala rin siyang tendency to rotate. So, ibig sabihin lang nun, kung balance siya, dapat yung resultant forces acting on the truss or kung gusto mo naka-components, dapat yung resultant forces acting on the truss and the resultant moment acting on the truss ay all equal to 0 if the truss is in equilibrium or balance lahat ng forces and moments. And that is our usual assumption when we analyze a truss. We assume na yung truss ay in equilibrium. So, ibig sabihin, again, dapat resultant forces sa kanya tsaka resultant moment all equal to 0 dapat. Last but not the least assumption is that yung internal forces na nag-a-act sa mga member ng truss, they all act on the centroid of the cross-sectional area of the member. Ibig sabihin, kunyari itong internal force na to, acting on this member. According to assumption number 5, that internal force acts on the centroid of this or on the centroid of the cross-sectional area of this member. Ibig sabihin, kung circular yung cross-sectional area nitong member na to, just like this. Kunyari, ito yung itsura ng cross-sectional area nito. So, according to assumption number 5, yung internal force na yan will act on the centroid of the cross-sectional area of this member, meaning dito sa gitna. Dito siya itong force na to, dito mag-act sa gitna nung cross-sectional area nito. So, that is our assumption number 5. So, now, let us move on. Let's go to the methods that we can use to analyze a truss. So, there are two methods that we will study that we can use to analyze a truss. The first one is what we call method of joints. So, anong sinasabi sa method of joints? Again, kung naalala nyo, dun sa assumption number 4 natin kanina, sabi natin, we are assuming na yung truss natin will always be in equilibrium. Ibig sabihin, lahat ng forces and moments ay naka-balance. Ibig sabihin, yung summation ng mga forces and moments dapat equal to 0. So, in equilibrium yung truss structure natin. Yun yung assumption natin. Ngayon, anong sinasabi sa method of joints? Sabi niya, if we are assuming and we are saying na yung truss natin ay in equilibrium, yan, dapat yung mga joints niya ng truss, dapat they are also in equilibrium. Meaning, kung idodrawing natin yung free body diagram ng mga joints, dapat yung tatlong equation of equilibrium will be satisfied at every joint. Ibig sabihin, dapat pag nag-summation forces horizontal, vertical, and moment ka at every joint, dapat they will all be equal to 0. Ibig sabihin, they will be satisfied. Yun yung ibig sabihin ng method of joints. Now, to better explain paano ba yung method of joints, let's say, for example, I have here a part of a truss. So, meron siyang joint na may tatlong member na nakakonect dun sa joint na yon. And itong tatlong member na to, tinanggal ko na siya from being connected dun sa kabilang end niya, sa kabilang end nitong member or sa kabilang joint. Ayan, tulad niyan. So, itong member na to, tinanggal ko na sa pagka-connect dito sa joint na to. But then again, since nag-disconnect tayo, sineparate natin yung dalawang connected parts according sa previous discussion natin. Pag nag-separate tayo ng dalawang connected parts, merong lalabas na internal force, usually equal in magnitude but opposite in direction. That's just like this one. So again guys, sana as of this moment, clear na kung bakit ganito yung direction ng force acting on a member of a truss. Bakit siya ganyan? Kasi nga, yung member ng truss ay two-force member. So, the only way para masatisfy yung equation of equilibrium sa isang two-force member ay dapat yung forces acting on it, dun sa two-force member, dapat collinear dun sa axis ng member kung saan siya nag-act. So, dapat, or sana, clear na yan. Clear na siya sa ngayon. So again, ito, yung member na to, tinanggal ko na from being connected dito sa kabilang end niya or sa kabilang joint. Then again, since nag-separate tayo ng dalawang connected parts, may lalabas na internal force equal in magnitude but opposite in direction. And ganun din dito sa member na to. Sineparate na dito sa joint na to sa kabilang end. So may lalabas na internal forces equal in magnitude but opposite in direction. So ngayon, hindi tayo dito sa mga joint na to concern. Hindi yan yung gagamitin ko para ma-explain yung method of joints. Ang gagamitin ko na joint ay ito. So dito tayo mag-focus sa joint na to. So sabi nga sa method of joints, if a truss is in equilibrium, dapat yung mga joint niya, just like this one, dapat in equilibrium. So dapat pag dinrawin ko yung free body diagram na to, dapat yung mga forces acting on it will satisfy the equations of equilibrium. So paano ka ba matodrawin yung free body diagram na to? So again, when we say free body diagram, it is an isolated view. So dapat i-isolate natin siya, i-separate natin siya from those things na nakakonect sa kanya. So i-separate natin tong member sa pagkakakonect dito. So again, nag-separate ka ng dalawang connected parts. Alam natin na may lalabas na internal force. Pero paano yung direction ng internal force dito? So para malaman mo, kung titignan mo yung free body diagram nitong member na to, may force na nag-act na pa ganyan dito. So to balance that, dapat may nag-act na force dito, equal in magnitude but opposite in direction. So then again, yung internal force na yan is equal in magnitude but opposite in direction dito. Sa lalabas dito sa joint na to. And ganun din yung gawin natin dito sa member na to. Separate natin siya from being connected dito sa joint na to. Then again, may lalabas na internal force because we separated two connected parts. Pero paano yung direction dito? Yung internal force dito, para malaman mo, check mo to. So, meron kang force na pa ganyan. So, to balance that, dapat meron kang equal in magnitude but opposite in direction na force dito para mag-balance dyan. Then again, yung internal force na lalabas dito, just like this, will be equal in magnitude but opposite in direction. Lastly, itong member na to, disconnect natin from being connected dito. May lalabas na naman na internal force. Pero yung internal force dito, paano na naman yung niya, yung direction. Dapat yung internal force na lalabas dyan will balance this force. So it must have equal in magnitude but opposite in direction. Just like this one, ganun din yung lalabas dito na internal force. Equal in magnitude but opposite in direction. Kasi nga, they are connected kanina pero sineparate natin. So may lumabas na internal force equal in magnitude but opposite in direction. So yung nagawa natin, ayan, tawag dyan, free body diagram nung member. So yan yung mga forces na nag-act dun sa kada member. And ito naman, yan yung free body diagram ng joint. So yan yung mga forces na nag-act dito sa joint. And take note, yung mga forces na yan, those are forces exerted to the joint by the member. So dito tayo magpo-focus sa free body diagram ng joint. Again, sabi sa method of joint, dapat kung in equilibrium yung truss natin, dapat yung joint just like this one is also in equilibrium. Meaning dapat it will satisfy the three equations of equilibrium. Summation forces horizontal tsaka vertical equal dapat sa 0 sa joint na to. Yung pangatlong equation of equilibrium, summation moment, di ko na nilagay kasi automatic naman satisfied siya dito sa joint na to. Kasi nga, yung mga forces acting on it are assumed na, 'di ba, concurrent dito sa sa joint. So kung concurrent 'yan, ibig sabihin pag nag-moment ka dito, automatic zero talaga yung moment. So automatic na nasa-satisfy na yung pangatlong equation of equilibrium. So wala na siyang kwenta, hindi natin siya magagamit to analyze this joint. Ang magagamit na lang natin ay itong dalawang equation of equilibrium na to. Pero since dalawa na lang yung equation of equilibrium na mga gamit natin dito sa joint na to, therefore, we can only solve two unknowns on this joint. Di ba ganun yan sa mathematics? Sabi sa math, kung meron kang dalawang unknown, at least dapat meron kang dalawang equation para ma-solve mo yung dalawang unknown na yan. So just like that, parang ganun din dito, binaligtad ko lang, kung meron kang dalawang equation, therefore, there are maximum of two unknowns na pwede mong ma-solve using this two equations. Ganun yan. Kung ilan yung unknown mo, ganun din yung number of equations na dapat meron ka para ma-solve mo yung dalawang unknown na yun. Or kung baligtarin man natin, kung meron kang dalawang equation, meron ka lang dalawang unknown na masosolve. Ngayon, pansinin nyo itong free body diagram ng member na to. Tingnan nyo yung force na nag-act sa kanya. Di ba parang pa-outward, palabas mula dun sa member. May tawag sa ganyang force na pointing outward mula dun sa member. Tawag sa ganyang force ay tension force. Ngayon, yung kabaliktaran niyan, which is this one, kung saan yung force naman ay acting towards the member, ang tawag naman dyan ay compression force. So, ito, ang tawag dito, obviously, same siya dito, palabas, pa-outward yung force mula dun sa member. Tawag dyan ay tension force. Ngayon, remember, ang mga force, they are vector. When we say vector, it has magnitude and direction. Ngayon, sa pag-analyze ng truss, usually to indicate kung anong direction ng mga force acting on each member, we usually indicate na lang if it is tension or compression force. So that is how we specify directions of the forces acting on each member. Ayan. So, tatandaan nyo na yan. So, hindi nyo na kailangan mag-specify ng exact direction nitong force na to na nag-active sa member na to. All you have to do is specify mo na lang if it is tension or compression. Depende kung paano yung direction niya. Pag pointing outward of the member, tension. Pag pointing towards the member, compression. Yan yung tawag. Now, dito tayo sa second method of analysis ng truss. Yung tinatawag na method of sections. So, ano naman sinasabi sa method of sections? Parang katulad lang din dito sa method of joint. Sabi ni method of sections, kung yung truss mo daw is in equilibrium, dapat kung hahatiin mo siya, yung truss mo, yung lalabas dapat na segments, dapat each of them will be also in equilibrium. Ibig sabihin, each of those segments na lalabas kapag hinati mo yung truss dapat will satisfy the three equations of equilibrium, which are summation forces horizontal, vertical, and moment. Dapat mag-equal yun sa 0. So to better explain methods of sections, say for example, I have here a truss, and then ikakat ko siya dito sa part na to. Kakat ko siya into two segments. So, merong left segment and right segment. So, since may sineperate ako na naman na dalawang body na originally connected, alam natin, pag nag-separate tayo ng dalawang body originally connected, may lalabas na internal force equal in magnitude but opposite in direction, equal in magnitude but opposite in direction, equal in magnitude but opposite in direction. So, yan yung dalawang segment nung truss na nabuo when we cut the truss into or using this cutting plane or cutting section. So, sabi sa method of sections, yung dalawang segment na yan, so separated yung dalawang yan. Sabi sa method of sections, yung dalawang segment na yan, dapat they are also in equilibrium separately. Ibig sabihin, itong mga forces na to, ito, dapat yung mga forces na yan will satisfy the equations of equilibrium, which are summation of forces horizontal, vertical, and moment dapat equal to 0. So, meaning dapat pag nag-summation forces horizontal, vertical, and moment at any point ako dito sa left segment na to, dapat they will all be equal to 0. Ganon din dito sa right segment. Dapat they will also satisfy the three equations of equilibrium according to method of sections. So, yung sinasabi ng method of sections. Again, anong sinasabi sa method of sections? If a truss is in equilibrium, dapat every segment niya, just like this one, dapat every segment niya will be also in equilibrium or meaning that segment must satisfy the equations of equilibrium just like the other segments. So, dapat parehas silang nagsasatisfy dito sa three equations of equilibrium. Ngayon, baka napansin niya yung mga direction na nilagay ko dito, paano ko nalaman na ganyan yung direction ng force na nag-act dun sa mga member na yan? Actually, hindi ko naman talaga alam yan. Ganyan, ganyan tayo pag mag-a-analyze ng trust. Eh. Hindi natin alam talaga exactly ano yung direction ng force acting on each member. Pero just like sa pagkuha ng reaction, pwede tayong mag-assume. Pwede tayong mag-assume ng direction. Ngayon, ang technique na lang na pwede kong ma-share sa inyo is pag nag-assume ka ng direction ng force acting on the members of the truss, always assume na pa-tension siya. Ibig sabihin, palaging pa-outward from the member or pa-outward with respect sa joint. Ayan. So, always assume na lang na pa-tension siya, pointing outward. Besides, malalaman mo naman kung tama yung assume na direction mo, di ba? Just like sa pagkuha ng reaction. So, paano siya malalaman kung tama yung assumption mo ng direction, kung pa-tension ba siya? Malalaman mo kung tama na pa-tension talaga yung force acting on a member if, again, parang sa pagkuha ng reaction, pag yung nakuha mong value nung nag-compute ka ay nag-negative, ibig sabihin, yung direction ng force acting on a member is not actually a tension force, but kabaliktaran, compression force siya dapat, pointing towards the member or pointing towards the joint. So, ganun yung pwede niyong gamiting technique pag nag-a-analyze kayo ng truss. Pag hindi nyo alam kung ano yung direction ng mga force acting on the member, always assume na lang na pa-tension siya. Since malalaman nyo naman kung tamang pa-tension siya, just like that, if yung makukuha yung value nung nag-compute kayo ay positive. So, pag positive, sabihin tama. Tama yung assume mo na direction, just like sa pagkuha ng reaction. Pag negative, edi ibig sabihin baliktad lang. So, hindi siya talaga pa-tension, hindi siya talaga pointing outward the member or pointing outward the joint, but pointing towards pala siya dapat. Yan, parang ganyan. Yan.